Okay, next question in the 2005 papers. Teacher said that a pupil to the nearest cent or percent, 1/6 is 70%. The pupil said so that means that the 2/6 must be close to 34%. Show the pupil is wrong. The simplest way to do this is to do the conversion for. Where's my pen gone? That one. Is to do the conversion that they're talking about yourself. So we need to do this 2/6 into a percentage. So 2/6 we want as a percentage, which is out of 100. Rearrange this, and P as a percentage would be 200 divided by 6. So therefore we're going to do this division. If I divide 6 into 200, 6 into 2 doesn't go, so carry the 2 to 20. 6 into 20 goes 3 times, carry 2. 6 into 20 goes 3 times, carry 2. We're now passing the decimal point, so put it in, and we need a new place. 6 into 20 goes 3, remainder 2. This 3 is going to continue, but we've got enough information here anyway. We've got 33.3%. I want it to the nearest digit, and this says round down. So rounding down, it goes to 33%, not 34, as they said here. If you actually do the calculation above 1/6, so 100 divided by 6, you actually get a decimal value of 1.6, and it keeps going. Nearest digit, the 6 rounds up, which leads it to being 17 to the nearest one place. This part you don't need to worry about, but this is what's needed in your answer. Moving on to the next question. Question 20. This is a scatter plot question, and you need to build up a couple of parts with it. Normally when you see a scatter plot, you also need to think about where the line of best fit is, and we're going to use that for this last one to actually expect how many fewer kilometres would you expect a tyre before it's illegal. Now, it's quite important I use a ruler for this, so it will take me a few moments to get the drawing tool to work properly. Currently the tread is at 1.6, so I'd have to carefully read up 1.5, 1.6, and there's no tyre less than this 1.6 on the current setting. That one is close, but it's not actually there. If we set this to 2.5, we're looking at all points that are below this line when it's put in the right place. Come on, break away from the gridding. Try just shifting it with a pen. No, I can't shift it. So actually that line is at 2.4. The 2.5 line is this slightly darker one through the middle here. So the points that it's failing for is that one. 1, 2, 3, 4, 5 are below 2.5. So 5 tyres would be illegal at that level. How many fewer kilometres would you expect the tyre to last before it is illegal? This is where we need the line of best fit. And what you have to look at is you look at the data, and we're still using these data points, and we're trying to find the best line to go through, evenly splitting that data. And I'll do that with a draw tool. So if I draw a line down, I think my line of best fit is going to do something like that. And the first figure I need is with the current value. So for 1.6 millimetres, what distance does it do? 1.6 is just one place above there. Read down, that's 30. What's the divisions on this? It's going to be 25, so it's 2 subdivisions for 1,000. So 1.6 comes down here, and we are just between those two. So I'm going to say it is 33,000. 1, 2, 3. That would be at 33,000 just there. 34, and there's my 35 halfway, so that's 33,000. At 2.5 millimeters of tread, we across 2.5, it's on that value, and we drop down here, and now we are 2 subdivisions below the 30, and that's 29,000 kilometers. So the difference, the fewer distance expected, is about 4,000 kilometers. You'd be given some leeway with this. I expect somewhere between 3,500 and 4,500 kilometers would be their expected answer. So you would be allowed anything 3,500 to 4,500 because it depends on where you put this line. That's my best guess. Question 21 is a Pythagoras question. So in a triangle below, a squared plus b squared equals c squared. Tick the correct triangle for this. Now, anyone who's learnt Pythagoras with me would treat this as being h squared, where h is the hypotenuse. Hypotenuse is opposite the right angle. So that's my hypotenuse. In this question, on the right hand side, they've said b is the hypotenuse. That's on the wrong side of the equation. This first one is correct. Okay, so this one is correct. That's the correct triangle. For the other one, I've now got to write an equation for this one. Hypotenuse, so we use h squared equals a squared plus b squared. That's my general form. And now put my variables in. Well, h is now b, so b squared equals a squared, or in this case, because of the way they've done it, c squared plus a squared. It doesn't matter which way around these two are. The important part is the b squared is equal to the sum of the other two sides. Scrolling on down, which triangle below does this work for? Now, the rule with Pythagoras is Pythagoras only works for right angle triangles. It does not work for any other form. Okay, so both of these are actually here to try and indicate that this should be a right angle. Do the calculations. That's 25 plus 65 gives me 90. So the angle left in this one is 90 degrees. This one, 100 degrees, this one's 80 degrees. So this one does not work, and the reason it doesn't work is the triangle is not right angle. Don't make complicated assertions, don't write paragraphs. A simple, clean statement like that is sufficient.